This is part 2 of the two-part video, and in the previous video we studied this little beauty, Dungeons and Dragons here, where our brave knight had to try and save the beautiful princess before being eaten by the horrible dragon, and he had the volcano and the forest, and we worked out the answers to these 4 questions here. We're going to do this again, but we're going to use state transition matrices now, which also allows us to answer other questions, for example E, F, G and H, which are much easier with transition state matrices. So I'll tell you what, let's just have a quick recap by drawing our so we have our dragon, and then what do we have? Sorry, we have a volcano, forest, the volcano, the forest and the princess. And the princess, once you're with the princess, you stay with her forever, happily ever after. Once you are inside the dragon's stomach or lair, you can never get out. From the volcano was a third, and third. So from the volcano to get to the dragon was a third. Volcano into the forest was a third. And the volcano to the princess's arms was a third. And the forest was a third back to the volcano, and 2/3 chance of getting from the forest to the princess. Let's just check that. Yes, it is. Okay, now we can write this here as a state transition matrix. Okay, so let's just write it as a matrix here, where this here is the current state that the brave knight is in, and this here is the next state that he will go to. So his current state could either be D, V, F or P, and his next state will either be D, V, F or P. And looking at it, well, if he's in D, then he stays in D. He can't possibly go to V, F or P. If he's in V, well, then he's got a third of a probability to go to D. He can't stay in V, and he's got a third of a probability to go to F and a third of a probability to go to the princess. If we are in the forest, then we've got a 0% chance here, forest going into the dragon in one step. We've got a third going into the volcano, 0 staying in the forest, and 2/3 going to the princess, which is that one. And finally, if we are already in the absorbing state, the princess, well then obviously we stay in the absorbing state, the princess. It's impossible to go to any of the other states. So this is the transition matrix here. Now just a couple of things. The rows always add up to 1, which is basically, if he's in a current state, he must go into some state. He can't disappear into thin air. So therefore, the sum of the probabilities is equal to 1. And just one other thing, sometimes the matrix is not written like that. It's actually written as the transpose, where this is the next state, and this is the current state, which is actually just the transpose of that. Now basically neither of them are wrong. The only difference will be when we do multiplication by row or column vectors, which we're going to do at the end of this video. If you are doing it this way, then you will right multiply by a column vector, and if you are doing it the way that we're going to do it in this video, then you will left multiply by a row vector. Just do whatever the syllabus that you're studying tells you to do. Okay, so basically, so we're going to do that later. So let's just have a quick look at questions E. We'll do questions A, B, C, and D later on, but let's have a look at question number E. Okay, and I'll tell you what, I'm going to change the colour of the pen here just to make things a little bit simpler. Okay, so let's go in green. Okay, so let's have a look at E. So we know that the probability that he is going to be in the forest at step 2. Okay, well let's do this sort of by recursion. Well, the probability he's going to be in forest in step 2, and obviously the first step is step 0. Well, it's going to be 2/3 whatever, because he's got 2/3 probability of going to the princess, and then plus whatever probability it is that you get from the princess to the forest, which we know is 0, plus the 1/3 chance that he goes to the volcano and then he steps back into the forest, which is 1/3 times 1/3, add the 0 chance that he goes to the dragon and then goes back to the forest, add the 0 chance that he stays in the forest in one step, because he can't possibly stay in the forest. Okay, and so basically when we work out what is the probability here, we're working out by hand at the moment, what is the probability that he's in forest in step 2 if he starts in the forest step 0? Well, the probability of that is basically equal to 2/3 times 0 because the 2/3 here, he's gone to the princess and he can't get back to the forest because the princess is in absorbing state. Add 1/3 times 1/3, which is basically he goes to the volcano and there's a 1/3 chance that when in the volcano in step 1 he goes back to the forest in step 2. Add a 0% chance that he goes to the dragon because there isn't even and then comes back to the forest, and a 0% chance that he goes from the forest to the forest. Now, if we look at our transition matrix, okay, so basically, and by the way, that equals 1/9. So we have already answered question E here. The answer is a 9th. But let's have a look at what it looks like in the transition matrix, because this is where the transition matrix becomes very powerful. So let's draw our transition matrix. Where are we? Let's draw it here. So okay, so we've got 1/3, 0, 0, 0, 0, 0. Just bear with me a sec because this is definitely worth it. 0, 1, 2/3 and 0, 0, 0, 1. So this is this is matrix, and here is DVFP. Okay, and the next step here is DVFP. And now let's do the transition matrix again, and we're going to multiply it by itself. But you're going to see why this works. DVFP. So 1, 0, 0, 0, 1/3, 0, 1/3, 1/3. 0, 1/3, 0, 1/3, and 0, 0, 0, 1. All I've done is I've done this transition matrix. And again, so let's have a look at what we just did. And let's put it back in green now. Okay, so what we just did was we said, okay, well, this is step 0. If in step 0 he is in the forest, then these are the probabilities that he goes to another state. He's got a 0 probability that he stays, that he goes to the dragon, a 1/3 probability he goes to the volcano, 0 probability he stays in the forest in one step, and 2/3 probability that he goes to the princess. Okay, now, so we're looking at whether he'd been in the forest in step 2. So this here is step 1, and here is step 2. Well, here's step 1, sorry, and here would be one after step 1, which is step 2. So what we're looking at, hang on a sec, if he went to the volcano, well, what is the probability that he goes from the volcano back to the forest? Well, it is this one here. And if he was in the forest, well, if he was in the forest, what's the probability? It's here. Well, basically, the probabilities are here. And so what we have is that in order to find out where he is at step 2, what we have to do is we have to square the transition matrix, and that will be t squared. And so basically, let's just go up here and redraw our transition matrix. I won't write it all in, DVFP. So this is at step 0. And now what we're going to do, this is going to be t squared, and here is DVFP. If we square our state transition matrix, then the positions in here, and this one here will be 1/9. Basically, each of the points in the transition matrix will tell us the probability, given that we start in one of these states here, that we are in step 2 in one of these steps here. So it's really powerful. And we can also add to that, t cubed is basically the cube of the matrix times by itself 3 times. That will tell us the probabilities if he's in step 0 here, where he's going to be with probability in step 3. Okay, so what we're going to do, let's have a look now at F. And we're going to do it by hand. So F, our brave, let's do it in another colour. That's a good idea. Yeah, let's do it in red. Okay, so F, our brave knight, is in the forest at step 3 if he starts in the forest. Okay, well, let's have a look. So he starts in the forest. What's the probability that he's in the forest at step 3? Well, obviously, if he goes down there, then he's not going to be in the forest at step 3 because he's already saved the princess. The only probability is here. He goes to the volcano, then he goes back to the forest, and then he goes back to the volcano. Oh, sorry, the probability that, where are we? Oh, no, sorry. The probability that he's in the forest at step 3 is clearly 0, because the only possibility is he either goes to the princess or the volcano. If he goes to the volcano and he goes back to the forest, well, that's only step 2. He's got to leave the forest again. So the probability F is 0. He cannot possibly be in the forest at step 3 if he starts in the forest. Let's have a look at G. And again, let's do it in a different colour. And we're going to do these using the transition matrix in a minute. But let's have a look at G. So our brave knight in the forest is in the forest at step 3 if he starts in the volcano. Well, this one, okay, he starts in the volcano. He goes to the forest, he goes back to the volcano, and he goes back to the forest. So in step 3, that is the only way that he can start in the volcano and be in the forest at step 3, which is a third times a third times a third, which is 1 over 3 cubed, which is 1 over 27. So the answer to G is 1 over 27. Finally, what colours have we got left? What colour have we got left here? Yellow. Okay, so let's do yellow. Finally, let's just do H, and we're going to do it at the moment. We're just going to do it. We're going to do it by hand, and then we're going to do it with the transition matrix. Okay, so basically, the yellow one, he has saved the princess by step 3 if he starts in the volcano. Okay, so basically, there's a third of a chance that he gets eaten by the dragon. There's a third of a chance that he saves the princess in step 1, which means he has saved her by step 3, and there's a third of a chance that he goes into the forest. Now, if he goes into the forest, we have to look at how many probability there is from being in the forest to saving the princess in 2 steps. Well, basically, he could go back to the volcano and then save the princess, or he could save the princess directly from the forest. All of those, he would have saved the princess by step 3. And if we just actually do the maths here, it would be 1/3 times 0, that's he gets caught by the dragon. 1/3 times 1, that means he goes straight into the princess's arms. And 1/3 is the one where he goes into the volcano. And that will be following the tracks. And you can see that it begins to get very complicated because you have to follow all of the possibilities. And this is where the state transition matrix becomes very, very powerful, because it follows it all for you. And this last one here is the one where he is not dead, but he's not with the princess by step 3. And if we add all of that lot, it gets us to 16 over 27. So basically, working out by hand, our brave volcano saved the princess by step 3. If he starts in the volcano, the answer to that is 16 over 27. Okay, now, they're not easy doing it like that. So now and especially, let's say, for example, if it wanted us to do it by step 4 or step 5, and especially if there were more than 2 transient states, you can see how it would become a right mess. The state matrix solves all of that. Okay, so let's have a look at t-squared. Well, t-squared, you can do it. If you were asked a question like this in an exam, you would actually have a calculator in order to be able to multiply the matrices. They certainly wouldn't ask you to be doing this by hand, but you can confirm this with any sort of matrix calculator. So this here is at step 0, what state they are in at step 0, and this here is the state they are in at step 2, because we are looking now at t-squared, and t-squared is 1, 1/3, 1/9, 0. Again, you can confirm this with a matrix calculator. I won't bother doing the calculation because otherwise it's just going to make the video far too long, and it's not really relevant to what we're learning at the moment. So this basically here is t-squared, which you can check yourself. Now, answer E is basically, let's go back to the question, sorry for the scrolling. Our brave knight is in the forest at step 2 if he starts in the forest at step 0. Well, let's have a look. By hand, we got 1/9, so let's have a look. If he starts in the forest at step 0, what's the probability that he's in the forest at step 2? Well, hey presto, it is 1/9. Good. Well, that's good. So that's answer number E. All right, now let's do t cubed, because t cubed will tell us what the situation is at step 3. And again, you would do this with a matrix multiplier, some form of calculator. So t cubed is going to tell us what the situation is. This again is at step 0, and this now is at step 3. And again, doing this with a matrix multiplier, you can do it by hand. It's just tedious, so I won't bother doing it. 0, 0, 1/27, 0, 0, 1/27, 0, 0, 0, 16 over 27, 23 over 27, and 1. Okay, so this is t cubed, which you can confirm by by matrix multiplication, matrix multiplier. So what it's saying now, we can now find our answers to F, G and H. So let's have a look at them. F was our brave knight is in the forest at step 3. If he starts in the forest, and I used a red pen there, so okay. If he starts in the forest, what is the probability that he is in the forest at step 3? Well, hey presto, it's 0. So that is the answer to F, which is what we confirmed. It's impossible that he could be in the forest at step 3 if he started in the forest. What's question G? G was our brave knights in the forest at step 3 if he starts in the volcano, and that one I did in blue, and our answer to that was 1/27th. Let's have a look. So if he starts in the volcano, what is the probability? Oh, it should be blue. If he starts in the volcano, what is the probability that he ends up in the forest? Well, it's this one here, 1/27th. Hey presto, that's correct. And finally, the answer was, what is the probability that by step 3 he has already saved the princess, given that he started in the volcano, and we did that one in yellow. Okay, so let's get a yellow pen. So given that he saved the princess and he started in the volcano, well, here he's in the volcano, what's the probability that he has saved the princess? Well, there it is, 16/27, which is exactly what we got by doing it by hand. Okay, so basically the transition matrix confirms what we can do and answers those questions, but also it allows us to answer the questions that we also answered in the first video. And the way we do that is by doing what's called a solution matrix. And what a solution matrix is that we do t to the power of n for some large n, large enough that you can see that these two numbers here, if we look at t squared, these two numbers here, basically anything in the transient states is becoming smaller and smaller, and the absorbing states, probabilities, is becoming bigger and bigger. Well, if you keep on multiplying the matrix together, i.e. the knight keeps on bouncing between the various states, in the end he is almost bound, well, he is bound to be in one of the absorbing states. It is possible that he could keep bouncing between the forest and the volcano forever and ever and ever and eventually die of old age. But the probability of that is 1/3 to the n, and for large n, that becomes basically 0. And so you will find that the transition matrix, the solution matrix for large enough n, has all of the transient states at 0, and it only has values for the absorbing state. Okay, so that's basically what we do there. And so if we look at the matrix t to the power of n for large n, and again you would do this with a matrix multiplier, so basically for large n, t to the power of n for large n is dvfp. You can confirm this with your favourite matrix multiplying calculator. Gives you 1/3, 1/8, 0, 0, 0, 0, 0, 0, 0, 0, 0. Transient states are all 0, 0, 5/8, 7/8, 1. Again, still, as per usual, all of the rows sum to 1. This is where you are in step 0, and this is where you end up, in which absorbing state you end up. So basically we can now answer the first 4 questions. What were the first 4 questions? Hang on a sec. The first 4 questions were, what's the probability he rescues the princess if he starts at the volcano and if he starts at the forest? Okay, well, if he starts at the volcano, here, the probability that he rescues the princess is 5/8, starting at the volcano, rescuing the princess. And the probability that he rescues the princess if he starts in the forest is this one, i.e. it's 7/8, and that confirmed by what we did in the first video, doing it by recurrence relations. Okay, and the third and fourth question were basically, what is the probability that he saves the princess if the probability that he starts in the volcano or forest is 50/50. Well, to do that, what we need to do is we need to multiply a row vector by our solution matrix, and the row vector would be 0, half, half, 0, which would be the probability he starts in the volcano, the forest, with the princess arms or inside the dragon's stomach. And this is question number 3. That's the probability row vector. And again, if you were doing this the other way, you would actually multiply by the column vector, and we multiply that by this solution matrix. And again, I won't write it all out. And that gives us, you can check this with a matrix multiplier, and that is dVFP. So basically this is saying if we start in these states with these probabilities and we left multiply it by the solution matrix here, which is t to the power of n for large N, we get out the answer, which is the probabilities that we will end up in each of the absorbing states. And so basically the answer to C was 3/4, which again we confirmed in the first video. And the fourth question was, what if the probabilities that he gets Star Trekked, transported into each of the 4 states was 1/4? Well, basically all we need to do is we need to multiply the transition matrix by the row vector quarter, 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 quarter. And that gives us, again, you would have to do this with a matrix multiplier, 3/8, 0, 0, 5/8, and that is the probability, dVFP, that's the probability that he ends up with the princess, given these initial state probabilities, and that again confirms the answer that we got in the first video. Okay, so you can see there are 2 ways of doing these questions. If you are just asked these type of questions, basically where does he end up, I think personally that the recurrence is easier. If you are asked where he is at various steps, then it's certainly easier to use the state transition matrix. Okay, well, I hope you found this useful. If you have, please spend 1 second pressing the little thumbs up button and subscribe to Aggressed Academy YouTube channel. Thank you.